Next, let us look into the part B first experiment, that is stepper motor, where we need to rotate the motor either in clockwise direction or anti-clockwise direction. So this program is written in C. So let us see how to write the program in C. So prior to that, speaking about the stepper motor, it is actually used in applications where movement is involved. A motor will convert the electrical energy into mechanical energy. So wherever stepwise movement is required, in that case we need to make use of the stepper motor. So here in C, first you need to include the header file #include reg51.h. Next, we need to excite the 4 windings. So now we control the movement either in clockwise direction or anti-clockwise direction by the bit patterns that is given into these windings. So any value can be given initially. So here we can see initially the value is given as 0x07. Next, this code is written for moving the rotor in anti-clockwise direction. So what is being done is the bits are shifted by 1 bit position to the right. So the next pattern is 0x0b, then again shifted by 1 bit position to the right, the pattern becomes 0x0t, then once again shifted by 1 bit position to the right and the pattern becomes 0x0e. Next, you need to declare the function that is being called, that is void anticlockwise void. Anticlockwise is the function that we are calling for the delay for exciting the windings. So next, a delay program is written for creating delay in the program so that the bit patterns are given and it is seen to it that the rotor rotates continuously either in clockwise or anti-clockwise direction. So here this is the main code, void main. So while 1 means while true, continuously the rotor is made to rotate in anti-clockwise direction. So this is the code for moving the rotor in anti-clockwise direction. What we need to do is we need to send the bit pattern to port 0. So why port 0? So the details will be given in the user manual. According to the specification, the data has to be given to a particular port. Okay, so initially what you need to do is you send a bit pattern and certain delay is required so the changes are visible to us. Then next send the next pattern. So all the 4 patterns are sent continuously, enabling the rotor to rotate continuously in the anti-clockwise direction. And this part of the delay, here you can see some time is given before you give the bit pattern so that the changes are visible to us. So next what we need to do is we need to compile the program and make sure that the program is error free. So next what you need to do is we will be using Atmel Flip software in order to download the program. So priorly what has to be done is the hexa code has to be dumped into the chip. So first you need to select project, there you need to select options for target. So here what you need to do is select output and you need to enable create hexa file. This has to be ticked, so ensuring that it has to be checked, saying that this is the file that has to be converted into the hexa file. Next you need to choose the Flip software. So here in the Flip software certain changes need to be made. So what you need to do is you need to choose the device. So go to device, select, and the device used is AT89C51ED2. Okay, click OK. Then here in settings you need to select the communication port. Okay, so choose RS232 and here COM3 port is being connected and baud rate it has to be kept as 9600. Then you need to connect it. After that go to file and you need to look for the hexa file. So the hexa file created his stepper.x. You need to download this program.